Alright, welcome back to Geometry B Credit 4. We'll be going over lesson 18.4, volumes of spheres, and that begins on page 19. Alright, so the first thing they're going to ask us to fill in is, on the explain, is the volume of a sphere. So here we'll be multiplying 4 times our radius, cubed. Now remember, cubed just means to the third power. So essentially, like let's say our radius is 5, that would just mean that would be 5 times 5 times 5, which is a pretty big number. I believe 125. Thank you, brain, for remembering that. And then this funny looking symbol that looks kind of like a table, it's not a table, it's pi. Remember, a great approximation would be 3.14, so just keep that in mind. I do take notes on the side in addition to what's on screen, so if you find it helpful to know what some of this stuff is, please pause and take notes. Alright, moving on. Here it says determine the volume of each given sphere. So they give us two spheres or ball shape. Well, sphere is a nicer word for it. It's actually the mathematical word for it too. So first things first, they give me the diameter, which is from end to end, which is about 12. Now remember, radius, just in case you're wondering, remember radius is halfway. So from the center to the halfway point. I know that's not a very good circle. Well, let's imagine that looks like a perfect circle. So essentially we're going to have to cut 12 in half, essentially dividing by 2 to figure out what the radius is. Take a moment and do that now. Unpause. That would be about 6. So we're going to plug in 6 in for radius. And go ahead and take a moment and go ahead and compute what 4 times 6 times 6 times 6 is. You got that? You sure? Okay. Now notice I'm going to still bring over my denominator of 3, my pi symbol, and hopefully you computed that out because it's going to be a big number, 864. Alright. To simplify this even further, let's divide these numbers out. 864 divided by 3. Take a moment and do that now. And unpause. Hopefully you did and you got 288. Now, one student did ask, what if I wanted to kind of have a number answer for this? So I could do that by multiplying 288 times 3.14. And no, I'm not going to compute this on screen for you, but that's another way you can get, essentially, this would be leaving your answers in terms, oh, sorry about that. We don't want to do that problem just yet, of pi. And then this would be kind of leaving it in its decimal or actual number form. Okay, both are okay, by the way. Now, computer, we are ready to do the next problem. So notice this one already gives us our radius, so we're just plugging stuff in. Alright, take a moment right now, and let's go ahead and compute what 4 times 7 times 7 times 7 is. Hopefully you're doing that. We're going to bring over a denominator of 3, our pi symbol. Last chance. Alright, so that would be about that amount, 1,372. Let's go ahead and take a moment and, yes, divide these numbers out. What would that be? Hopefully you got that and you got this. 457.3 pi. Again, you can leave it in terms of pi, and that's totally fine. But if you want a decimal actual answer, we could multiply 457.3 times 3.14. Again, I'm not going to do that on screen, but you have the option of doing so. Alright, now going into composite figures, essentially when we have two shapes creating one. And in this problem we have a composite figure as a cylinder with a hemispherical hole at the top. So essentially we're kind of cutting a half-shaped ball out of this cylinder. So what we're going to do first is we're going to find the volume of our sphere. In this case, again, they give us our diameter, which is 7. So let's go ahead and take a moment to figure out what is half of 7. Unpause. Hopefully you found that to be about 3.5. Let's go ahead and plug that in for a radius. And just like we did before, let's go ahead and just compute this out. Hopefully you paused and you tried this out. I'm going to go through each part. And we got about that much. We divided that out. 57.16 pi. We can kind of compute this out as well by multiplying by 3.14. Now notice I took it all the way through because we are going to use our number answer. We're going to find the volumes of two shapes and kind of do some stuff with those volumes. Alright, now because it's only half a sphere, not a whole sphere, we're going to divide by 2 because we are only dealing with half. Take a moment and do that now. And unpause. Hopefully you did that and you worked that out to be about 89 and some change. Okay. The next thing we're going to do is we're going to find the volume of the cylinder. In this case, since my radius was 3.5, I kind of wrote that there. And notice since it's only our cylinder, even though they don't label it, we can kind of infer that essentially it's as tall as the radius, which is also about 3.5. So let's take a moment right now. Let's go ahead and fill that in. Height of our prism is about 3.5 and the radius is as well. So take a moment right now. Let's go ahead and compute that out. And unpause. Hopefully you did that and you worked that out to be about 12.25. Multiplying out the numbers. Figuring out a decimal value. Now one student did say, you know what, I just don't want to do all that work. On my calculator, I'm able to actually compute all of this and get the same answer. All I did was I said, okay, well 3.5 squared is 3.5 times 3.5. Pi is just 3.14. So instead of pi, they used that. And then I'm just going to do another 3.5. And guess what? I still got what you got without doing all these steps. Either one's fine, just so you know. Okay. Now you're wondering, well, now that I have these two volumes, what do I do with them? Well, essentially we cut out half of that sphere from the cylinder. So cut out, when you think cut out, take out, do you think adding or subtracting? Subtracting. So we're going to subtract these two volumes, the bigger volume from the other, because, you know, volume's never negative in the real world. And take a moment and do that now. And unpause. Hopefully you got the answer about 44.9. Alright. With that being said, we're going to move right on to the checkpoint. So here we're going to find the volume of our sphere. Again, they're using the half of a sphere or hemisphere. So take a moment right now and compute out the volume for a sphere first, and then we'll cut it in half. Unpause. Hopefully you did that. And again, I'm going step by step. But if you found a shortcut, you can use that. Again, we're going to use the decimal form of that, so please feel free to go ahead and use that. Again, since we're only using half a sphere, let's go ahead and divide that by 2. And what would that be? That would be about 56 and some change, right? So now we're going to find the volume of our box. And I kind of drew that here. So remember the volume formula for a box is about the area of the base times height. In this case, the area of our base is going to probably look a little rectangular rather than spherical. So we're going to multiply these two numbers together. And our height's about 4 centimeters. So let's take a moment right now and let's go ahead and work out that volume. And unpause. Hopefully you figured that out to be 320 and you're like, now what do? Do I subtract them like the last one? Well, since that hemisphere is on top of the box, we didn't take away, we actually kind of put it on top, we added to it. So let's go ahead and add those volumes. Alright, so hopefully you did that, you worked that out. You do have some homework to do, so make sure you're completing that. It's from your textbook. I'm going to kind of show you some of the questions from the textbook that you're going to see. So make sure you're getting help with any of these problems. If you're seeing them and you're like, I don't know how to do this one, I need more support, please come into the center. Again, we have awesome teachers, tutors here to help you with any and all of these problems that you see before you. All right, catch you on the next video and take care.